question is from AIPMT 2015. Here it says a mass M is rotating horizontally set on a table with a velocity v0 with a radius r0. Now there is a thread here, so by pulling the thread we are reducing the radius to r0 by 2. The final radius becomes r0 by 2. That means now it will rotate in a smaller circle, right? We have to find the final kinetic energy. Now let's analyze the problem. The mass is rotating horizontally. That means there is no change in gravitational potential energy. Okay? Now we are applying a force by pulling this string to reduce the radius. Now we do not know the magnitude of the force, so we cannot calculate the work done by the force even if we wanted to. If we could have found out the work done, maybe we could have used the work energy theorem. Now that option is ruled out. Let's see what else we can find from the given situation. The mass is rotating in a circle. So in rotational motion, we know what will come to our mind is, one is angular velocity omega. Next, what should come to our mind is torque, because the cause of rotational motion is torque. Now, do we have torque here? Are we applying torque here? See, we are applying the force along the thread in this direction. So the force is passing through the axis of rotation. See, it is rotating like this horizontally. So the axis of rotation is through the center. The force is passing through the axis of rotation. That means in this case torque is 0. Clear? So from our analysis we have found that in this case, though there is a force applied, the torque is 0. Clear? When the torque is 0, it should come to our mind that angular momentum is constant. Okay? Now, what is the angular momentum here? Angular momentum is m v0 into r. In this case, r is given as r0 at this point. Okay. Initially, when it is rotating with a radius of r0, the angular momentum is m v0. It is linear momentum into r0, the distance. This is the angular momentum which will remain constant. That means it will remain constant means the final angular momentum m, let's call that velocity as v2 into the distance r0 by 2, the radius. So this is equal to this. From here we get the relation, the v2, that is the velocity, the final velocity at a radius of r0 by 2, v2 will be twice into v0. Clear? R0 cancels out, m cancels out, so v2 becomes twice v0. That means the velocity at this radius is twice of the velocity of that. To find the final kinetic energy, we all know kinetic energy is equal to half m velocity square. At this point the velocity is v2 square. So this will be half m, v2 means this, so 4 v0 square. So 2 and 4 will cancel out, it will become 2m v0 square. This is the final kinetic energy, and if we see at the options, this is option D. So in this question, option D is correct. in problems like this, when we analyze the problem, we have to proceed step by step. So from the analysis, we saw that torque applied is 0. So that meant that angular momentum is constant. From there, we got the relation that V2 is equal to twice of V0. So that gave us the kinetic energy. Clear? So this is the approach. This is the way you should think.